All right, so I'm really late to the launch of the Hyte X50 case, but it's not without good reason. It's because I spent the last month kind of figuring out testing methodology so I can start including temperature testing and comparing it to other cases and stuff. So although this one's really late, even though you saw our glass breaking video about this laminated tempered glass, we finally finished the testing. And it's quite interesting, the results. So we're gonna talk about the X50, Hyte's new bubbly, friendly, very different departure from where they normally design their cases. We'll talk about it. So the X50 is much different than like the Y60 and the Y70 and the other cases that you're used to. It's very bubbly. In fact, to me, it just looks like a big microphone. Comes in a couple of different variants. You've got the Flow, which basically replaces the tempered glass, the curved tempered glass side panel right here, with a fully perforated side panel similar to the back panel like this, making it essentially just one big giant open ventilated chassis. What the fuck is calling me? But the one we got right here is the tempered glass, the curved laminated tempered glass side panel. And we did a video already talking about how strong the laminated glass is. Here's a little clip of that. Yeah, that was a steel 5-pound plate that bounced off the glass. So if you want to see what it took to break that glass, I'll put the link in the description down below. But as you can see, the layout of this chassis is very, very different from most chassis. In fact, pretty much all of the top exhaust is essentially removed from this case. It's replaced with this PSU chassis, or chamber if you will, where it actually gets fed air from inside the case. Typically, most cases that you would mount the power supply on the bottom do have ventilation above the PSU, so if you wanted to flip the power supply so it can be fed air from inside the chassis, you could do that. But that's almost become like the cardinal sin of PC building. If you put your power supply in and it's not pulling air in from under the chassis, fresh air, people really tend to frown upon that, which is kind of funny because I almost always used it as an exhaust to help pull more air out of the main chassis for a higher exchange rate of fresh air going in. To be honest, if your power supply is spec'd high enough, it's a good enough 80 plus rating, or it's a good enough cybernetics rating with the new rating, it's not gonna matter. The power supply, it's probably rarely gonna ever turn its fan on unless you're really loading the system anyway. But this right here, the only way you can pull air in is through the main part of the chassis, because if you look at the top, you can see it is completely solid. So it's really different in that aspect. Now, this is our standard case testing hardware. You'll notice that our fans are in here. These are the Be Quiet Silent Wings Pro 4s. They do have a switchable speed on the hub. We have it set to the UH, which is the high speed. The three settings around there is medium, high speed, and ultra high speed. It's funny there's no low. They could have called it low, medium, high, but I guess I don't consider low. The high speed setting on the hub on the 120s, when set to 50% in the BIOS and on the hub setting it's set to HS, then we get about 2,140 or so RPM out of the fan. Now they do max out at 3,000 RPM, but that's if you're doing 100% and you have it set to the UHS or ultra high speed, which is not where we were set. So in terms of the testing hardware, we are running a 13900K with locked E cores at 4.2 gigahertz and locked P cores at 5.2 gigahertz with locked voltage at 1.25 with a PL1 and PL2 set to 253 watts. The RAM that's in here is some Crucial Pro DDR5 running at 5600 mega transfers, nothing crazy. And then the graphics card is a RTX 4080 Super NVIDIA Founders Edition card. I didn't want to go with a 90 tier card because I didn't think that was very indicative of real world usage. In fact, the 4080 Super is still probably a bit high for real world, but it's a 300 watt card that allows us to still generate some heat in the chassis that we get to measure how well it can exchange the heat. And then the platform it's on is a Z790 Tough from Asus. No real reason there other than it had a gap between the graphics card and the cooler, so I could technically get the graphics card out easier, but it has an eject button too for the PCI Express slot. So whatever, it's just the hardware that we use, plus it's pretty. And for the tower cooler, we have a Noctua NHD15S Chromax in black with the second fan on there. It's funny, this kind of barely fits inside the Hyte, but it does fit with about 5 millimeters of clearance. All right, so let's talk about some of the dimensions here, because obviously with this cooler, it's very close to the side panel, so we want to talk about some of the dimensions. Overall, it's 63 liters of volume. The case dimensions are 485 millimeter by 510 millimeter by 255. It supports up to EATX motherboards. That's up to 10.6 inches wide. Power supply length up to 223 millimeters. Because the cables still have to come out and fit within the shroud, that's not the distance of the shroud, by the way. The power supply needs room behind it for the cable, so keep that in mind. Even though your power supply may be an old school long power supply, if it's the length of the shroud, it's not going to work because of the fact that you need cable room on the back. This is actually where the Corsair shift power supplies really come in nicely here, because they point out towards the back rather than towards the front of the case. So you can actually go with a longer power supply if you needed to, but the shift power supplies are also like 80 plus gold and 80 plus platinum, and they come out sideways, so they're not even as long as they need to be anyway. Okay, so you can fit 3 120 millimeters in the front for intakes, 3 120 millimeters on the side for more intakes if you want, and 3 120 millimeters on the bottom for 3 more intakes if you want, because of the fact that this is designed to be a heavily positive pressured case with only one 120 millimeter exhaust fan. This crazy ventilation, or this mesh design we'll talk about. It's the first time we've seen a case come out with this type of mesh. It's intended to get the positive pressure air movement out as fast as possible. And we've already seen through a lot of independent testing, heavily positive pressure design tends to perform pretty well. And Hyte's really leaned into that with the fact that there's only one active exhaust fan. I wouldn't recommend turning these right here on the motherboard tray into an exhaust. Otherwise, it would just be pulling fresh air from the front and then the bottom right out the side before it takes any real heat from the component with it. We need the air to move over the components to give us proper cooling, especially if you're running a tower cooler like this one right here. And you want air to be moving across the motherboard, because all of those surface mounted devices have to be cooled as well, especially with your VRMs and your PCH and your RAM. Your SSDs, all of those things also generate heat, so you need to have air moving across those components. And the way that this is designed right here, and the way that I have it set up with the 3 intakes on the front and the 3 intakes on the bottom, and the 1 exhaust in the rear, plus the tower cooler moving air through the CPU, we definitely are getting airflow over those surface components. So for cooler height, it'll fit up to 170 millimeter max height. That's pretty tall. In fact, if it can fit this Noctua cooler with the 140 fans on there, it can fit any air cooler. And obviously it can support up to 360 millimeter AIOs in this, no problem. But that's one of the reasons why I run the big cooler, is because that's one of our tests too, is can it fit a big cooler in there? And then when it comes to graphics cards, we have a GPU support of up to 430 millimeters in length and 160 millimeters in height. All right, let's talk about some of the nuances here, showing you the back. You can see it's very well thought out when it comes to the cable management. This is that area I told you about right here where you tend to need to have room to move your cables out. Power supply I'm using here is just a Montech Centuri 2. I think it's a 1050 watt, something like that. You can see it's very short, lots of room right here. In fact, I didn't even utilize this area for cable management, because where the power supply is, we need a lot of the cable run to actually be able to reach the components. And that's where one of my first problems was. We'll talk about that in a second. I am running this Cooler Master fan hub. There's no hub included with this. And the reason for that is because I can use one input to control the speed of all the fans when I'm doing the noise normalized testing. That's one of the things that we are doing is 42 decibel noise normalized. Now don't confuse that with like those sound chambers like Gamers Nexus is using, because their noise floor is so low at like 13.5 to 16 decibels, which is like hearing the blood flow through your body level of quiet. Having their noise normalized at like 26 decibels is still like around the same speeds as what we're dealing with higher noise floor. So you could have a whole discussion about that, but I did talk with him a little bit, and we kind of figured 40 decibel noise or 40 decibel normalized is a little low for the noise floor in this room, even though I have it as soundproofed as possible and with everything off, all electronics, all lights and everything, is still about 33 decibels. So yeah, you can see that if we don't bring up the noise floor, or excuse me, the noise normalization a little bit, then it's not going to be indicative of real performance of the case. The bottom line here is that all of them are tuned to the same noise normalization, which is important. And we normalize that at 1.5 meter, or excuse me, a half a meter rather than 1 meter. Again, we need to get closer to the chassis so we can actually hear the difference between them when we're doing our dB testing. Something maybe in the future we can look at redesigning a sound chamber to do the normalization in, and then do the testing in a controlled environment like this room where the temperature is 22°C all day, every day, regardless of how hot it is or how cold it is outside. With that out of the way here, you can see this is a magnetic cover or fan controller, which is kind of nice because I can just boop right there. Speaking in terms of drives, the only drive mount that you have with this case is this interesting kind of a stackable drive caddy, if you will. You can mount a 3.5-inch hard drive through these holes right here to the top, and then you can still have 2 SSDs mounted inside right here, and they've got these holes that you can pass your screwdriver through to mount it. So you basically get like a 3x3 stack of hard drive right here if you need it. Or you could take it out entirely for a little bit extra cleanliness if you wanted, but obviously I left it in because I don't want to lose it. It is not adjustable in any way. It has one location where it mounts. It doesn't go forward, it doesn't go backwards. It just is the way that it is. And then it's held on by this captive thumb screw. You can see right here a very large cutout in the back that tends to kind of cover all the bases of where the CPU socket might land on different motherboards, allowing you to put on your cooler retention bracket if you need to. You do have Velcro zip ties or Velcro straps right along the side right here that you can cable manage. But as you can see, I didn't use them. I didn't really feel like I needed to, but they're there if you want to. And this case is fully built in right now. It does have literally everything plugged in with the exception of the HD audio because I never use it, so I just always leave it flopping around right there. But while talking about the back here, it's kind of interesting that this is a case that was released in late 2025 that does not support any BTF or back-to-front designs when it comes to motherboards. That's something even the cheapest case brands are now starting to implement. I'm kind of curious why they chose not to support BTF. There's clearly plenty of depth right here to be able to allow that. Now, you more than likely would have lost your hard drive cage, but I think I'd rather have the option to know, okay, if I ditch the hard drive cage, if I'm running all NVMEs, I don't need that anyway. I would have liked to have known I had the option to use a back to front. So this does not support back to front, which is unfortunate because I feel like the layout really kind of calls for supporting that. There's plenty of depth there. Okay, let's talk about some of the nuances of building in this thing. Hyte does not give you a very thoughtful way of getting cables from the front fans to anywhere else without the wires showing. You kind of have this channel sort of like down through here where they have the front cables going through. The problem is the length of the run from this fan and this fan, especially this fan, to go down and then all the way across to get to anywhere is very unlikely to fit and to fit the run. In fact, you can see right here, I have a cable extension on that fan because you can see where it ends. It ends right there, right around the grommet. So cable run length, not great for the front. I wish there was a better thought out chamber that would give you a little bit more room to be able to hide those fans. Now, to me, this is the only eyesore of building in this case is if you have fans running across right here, or cables, I should say. So that's a downside. I guess if I ran extensions, I could run all of them through that little chamber. To me, it does seem like a little bit of an afterthought though. The run lengths are very long. Speaking of run lengths, that's the cable for this power supply, the 12 volt 2x6 cable, to go to the graphics card. You'll notice that's not the one that's installed on the graphics card because the run to go from here to down to across and up into the graphics card cleanly without it coming across the top and looking stupid in my opinion, this cable was too short by about 100 millimeters. So I stole from one of our test benches our extension cable, which is just a much longer individually sleeved 12 volt 2x6 cable that barely had the length to make it work. Now I tried running it different ways. Instead of going through the grommet and out, I tried going straight down through the motherboard. The problem is where the motherboard opening is at the bottom is actually farther down than where I'm coming through with the grommet, which ate up some of the length, and it actually couldn't make it. It got to about right here and couldn't get it plugged in. Remember, you don't want huge strain on the cable connector itself. You want nice relief, that way it's coming out straight, and you definitely don't want it pulling sideways. If it pulls sideways, it can start to pull out those side pins, and then you know what that could potentially lead to. So although the power supply placement is unique and neat, you need to keep in mind, depending on your power supply cables, you may need to buy another cable to connect your power supply to your graphics card. So that's just something I needed to point out. It was the first WTF because I did a previous build in this that before we did our temperature testing and moving to our standardized hardware that we use, I used a regular, like a 9070 XT that just had regular 8-pin PCI Express cables. those reached fine because those tend to be longer than 12 volt high power. So yeah, that's a negative right there. You just need to keep that in mind. I could have come from right here where the 24 pin is and come across and connect it to the top, but that just looks stupid. It just was not tidy. So by me wanting to go down underneath the card and kind of hide it means I needed to use a different cable. Let's talk about the front here real quick. So we have 2 screws here that hold this front bracket on. And you can see by removing the front bracket, and they are tied into the fans, I may not have a lot of slack here. This top and bottom bracket right here, as you can see, we can unscrew, and we have 3 or 4 different, we have 4 different placements we can put that bracket to either push the fans more towards the grill or the vent, or more inside the chassis. Why would you need that? Well, that's honestly just for being able to kind of fine tune your radiators if you're using AIOs or any sort of an open loop, and be able to adjust, how far they sort of encroach into the chassis. I think it's nice for one reason and one reason only, personally. The closer your fan blades are to mesh, the more turbulent sound you'll get from the blades passing by these openings. The more volume of air you can get in front of the fan blade from the mesh material, that pocket of air right there as the air is moving through the fan blade helps create a vacuum too that pulls air through the mesh. So it's kind of like if you have your radiator and you have your fan right against your radiator, and then you take your fan off later on and you notice a perfect dust shape that matches the pattern of your hub and your supports for your hub. If you were to be able to space that away, you would notice that you would have a very even dust pattern because you have a volume of air in front of the fan, so you get better airflow and static pressure through the item. So what I did was I actually pushed these fans in slightly so that we get a really nice volume of air between the fan and the front grill. So it's kind of difficult to see through the grill, but it allows me to be able to get a nice solid volume of air in front of it. All right, I did do temperature testing, like I said. There's 3 cases on this chart. The chart is going to grow from here, just like our GPU charts. Remember when we started that? My God, does that feel like an eternity ago? But that was just, hell, coming up on a year now. Holy crap.
Almost perfectly a year.
There's only 3 cases on this chart. We have obviously the Hyte X50. We have the new fan favorite amongst a lot of people, which is the Haven BF360, which stands for big ass fans, as far as we're concerned. It'd be BAF, but still, big ass, BIGGASS.
Yeah, because that's the actual brand name of fans, right?
Is it?
Big ass fans, yeah.
Oh, I didn't know that. And then the Montech King 45. Now these are 3 very different price points for cases. And we're gonna talk about the methodology real quick before you see this. I kind of talked about this a little bit. I chose to do only the configuration where we fill out the fans in the case's capability. I'm curious about what the case is capable of, not what the case ships with. Let me tell you why. This case does not come with fans. That does not mean that this case is intended to be used without fans. It is not a passively cooled case. It means Hyte says, supply your own damn fan. We sell fans if you want them, but most brands know most enthusiast builders, and let's face it, Hyte definitely is an enthusiast brand. Okay, any cases that are over $150 are enthusiast brands, okay? But they know that most enthusiasts are going to probably want to use RGB fans or maybe a daisy chainable fan, or there's a million fan options out there, especially in the 120 millimeter size. So this is the config I tested this one in. I did not choose to put anything in the side right here because I feel like 9 intakes would be a bit excessive for this case. I think this is a nice to have if you want to do radiators or water cooling or whatever. But I chose to leave this open with 3 intakes in the front and 3 intakes on the bottom. The King 45, I ran 3 120 millimeter intakes, the same Be Quiet fans right here. We use the same hardware, including the fans in all of our testing. We ran 3 intake on the bottom, 3 exhaust on the top, because that is a chimney style case, and the 120 exhaust on it. So it's 4 exhaust, 3 intake, which still led to a positive pressure situation, which is always interesting. When I love the smoke tests, it really teaches you things visually that you may not have even thought. Now the BF360, we ran 4 of their 180 millimeter fans in that because those are the capabilities of that case. Now we don't have Be Quiet 180 millimeter fans. But we do have Be Quiet 140 millimeter fans and 120 millimeter fans. So cases that support 120s and 140s get the Be Quiets. The BF360 is kind of an edge case because it uses 180 millimeter fans. We had 2 intakes with 180s, 2 exhausts with 180s, and then 1 140 exhaust. The airflow in that thing is insane. So is the noise, because to noise normalize the BF360 to 42 decibels, I had to run those fans at like 40%. All right, let's get to the charts. Okay, so this is the temperature over time chart for the X50. This is on AIDA64 Extreme, both cache and CPU. We're not doing FPU. FPU just pretty much puts the CPU automatically into like a thermal limitation state where it's just gonna go right to 100 degrees over time anyway. As you can see here, 6 120 intakes, 1 120 exhaust, 42 dB normalized, 15 minutes. You can see the blue line here, that's the P-core average, and the red line here is the E-core average. I chose to put the VRM on here because I'm just curious as to how temperature and airflow affect the VRM. Because remember, like I mentioned in the beginning of this video, you need to have airflow over the motherboard components, otherwise they're gonna start to be victims of heat saturation, if you will. Now, I decided to not only run at 42 decibel normalized, I chose to also run at 100% speed on the case fans to see what would happen. Now, on these Be Quiet Silent Wings Pro 4s, I still left it at the high speed. I did not go to ultra high speed. So they're just maxes out at about 2,500 RPM on that one. You can see right here, it's gonna be kind of difficult to see because they're laid on top. There's a slightly transparent line. Those are the previous numbers with the 42 decibel normalized. With the fans at 100%, we actually saw a slight increase in temperature on both the E-core and the P-core averages, but you'll notice the VRM temperature is about 1.5 degrees below the previous line. So that tells me the air exchange rate inside the chassis is increasing with the max airflow. But the only reason I can figure out that the CPU temps might be slightly climbing could be due to turbulence, I'm assuming. I had to do more investigation to figure out why at max speed, all of the temperatures went up slightly, including even the GPU. But we'll talk about that in a second. But this is not unique to the X50. All 3 cases saw a slight increase in temperature for the CPU when the fans are at 100%. So that means to me there's something else happening. It's not chassis related. I honestly believe it to be turbulence related. It's definitely showing a diminishing returns though, where you're trading off a lot of noise and a lot of dust for literally no benefit on the CPU. Now here is the GPU test. This is with Cyberpunk 2077 running at 4K RT high preset. Same intake and exhaust, 42 decibel normalized. You can see our GPU core temperature hovering about 55 to 57 C, bouncing around. Our hotspot is a little north of 65, 67 C, and then our memory junction temperature right in between the two, hovering right around 63 or so C. 100% fan speed though, same story, slightly warmer, which is so odd to me. So I can't wait to kind of investigate this a little bit more, maybe with some higher speed cameras and our smoke tests to see what's actually happening with the air. Because one thing to point out is although I did increase the fan speeds to 100% on the chassis, the fan speeds on the tower cooler and the GPUs are fixed. They are 52% on the GPU, and it's approximately 80% on the NHD15S Chromax. So I'm almost wondering if, because the fan speeds are not increasing on the coolers themselves, if that is just now causing a weird turbulence situation. So there's definitely a balancing that needs to take place between chassis fans and your cooling fans for your GPU and your CPU. Now let's go and talk about temperature graphs right here. Again, it looks kind of funny because there's only three cases on here. This list is gonna grow though. So when it comes to temperatures in AIDA64 Extreme, 42 normalized for the CPU, you can see the Hyte is leading the chart with a P-core average at 75 and an E-core average at 72. You'll see the Haven 360s at 77 and 73.9 respectively, and the King 45 is at 78.1 and 75.5. I specifically chose not to show temperature delta over ambient because I had a lot of requests when I talked about how I'm gonna do my charts. A lot of requests actually for people asking me, don't show delta over ambient. To them, they don't feel like that's very useful. They want to know what the actual component temperature is. So I chose to just go ahead and do it this way. There's lots of different testing methodology out there. You can find a lot of different results. But you can see the difference between the King 45 at the hottest temp of 78.1 versus the Hyte X50 at 75. It's 3.1 C difference on the CPU, on a fully locked down CPU. So obviously that just means there's clearly a little bit of a not starvation, but definitely an overall hotter chassis inside the King 45 than there is versus the X50, which is why we're getting better temperatures. Now, as soon as we set those to 100%, you can see now there's the small climb I talked about. So we went from a 75.0 to a 75.7 on P-Core average on the Hyte X50, 72.9 for E-Core, and then 78.0 and 75.3 for the Haven, and 78.3 and 75.1 for the King 45. So really, really close together in temperatures, but seeing any sort of temperature increase with 100% fans to me is just really interesting, and I'm looking forward to trying to figure that one out. GPU temperatures now, when we look at 42 dB normalized, Hyte X50 leading the chart again at 63.4. This truly surprised me. I fully expected the BF360 to win this because of the major amount of CFM and airflow exchange rate with the 4 180 millimeter fans and plus a 140. But as you can see right here, clearly the Hyte X50 is doing something right, even though it's the exact same temperature at 63.4 for the hotspot and 55.5 for the GPU core. The Haven 360 is 63.4 as well for the hotspot and 55.9, so almost a half a degree warmer on the edge temp. And then 64.8 for the King 45 and 56.9 for the GPU hotspot versus core. So the X50, although barely a win, is still a win, which is so funny to me because there's only one exhaust. Typically, when you have a GPU generating a lot of heat, that heat can sort of collect at the top of the case, which is why most cases have top exhaust, so you can let that heat out. But the fact that this heat is being forced through the back of the case, it's really curious to me that that single 120 millimeter fan and just the massive amount of ventilation in this chassis is able to get the job done and do it just as good, if not better, than a case that has easily double the amount of fan surface area. Now, if we set the fans to 100%, same story. Actually, slightly different story in this one, I guess, on the GPU. The temperatures came down ever so slightly. So 62.7 and 54.9 for the X50, 63.1 and 55.6 for the Haven 360, and then the King 45, 65.1 to a 57.3. Okay, so again, surprising to me that a case like this that only has a single active exhaust, with the exception of the power supply. I didn't actually monitor the power supply fan at all. I do have the 0 dB mode on the fan for the power supply. There's a switch. I have it off. But clearly the amount of ventilation in this chassis, I mean, heat can go out the side panel right there as we showed. I would assume it would be even better potentially if we had the vented side panel here. But as we've seen, when you have bottom fans like this blowing up, if you have too much mesh right here, a lot of that cold air can escape the chassis rather than bouncing off the glass and going up into areas that it's needed. So I also am wondering on the other cases when the fans go to 100%, especially when we're running top exhaust, if that air that's exhausting out the top, if those fans can overpower these fans by pulling more of that air out rather than having these fans be able to overcome, especially a major updraft situation, right? So if we think about the BF360, those are two 180s in the front and two 180s on the top, no bottom fans at all in that chassis. So it made me wonder if those two 180s at the top running at high speed, which are what, 40 millimeter thick fans, and the amount of volume those fans can move, and because these fans didn't speed up, they're stuck static at 80%, if they were starving the CPU cooler from a little bit of the air that it needs. Remember, when we did our King 45 review, we showed without top fans at all, the CPU cooler was able to bring like air in through the top, even though it had updraft fans. So that's why it would be interesting to maybe revisit this subject later on something like the King 45 and see if the temperatures are better with no exhaust fans on the top versus having exhaust fans on the top. Now, we've talked about this before. We've done testing where we have tested those as an exhaust, we've tested those as an intake, we've tested those as one intake in front of the CPU and one exhaust behind the CPU, and we found that it was so negligible that it didn't seem to matter. And that was through a lot of testing. And so again, it's gonna be one of those things I think we're just gonna have to really visualize the airflow in the situations with the smoke, which is what we'll get to in a second. But this is such a unique style of vent. I can't imagine how much labor is involved in this, because a machine has to basically, because these are flat, and then a machine has to clamp on and twist, clamp, twist, or however this machine does it. That's a lot of work considering the whole back of the chassis looks like that. Now, Steve did a really neat video where he used the Schlieren camera to actually see whether or not this does smooth out the airflow, because the idea here by twisting these is one, if you have like, doesn't matter if it's a hexagon or it's an X or it's a circle, having a flat piece of metal with that cutout, you still have all the flat metal that's resistance. That's what porosity is the amount of closed off area versus open area. Well, they make the porosity on this significantly in favor of open by taking it and turning it flat like a blade. Plus it straightens the air out as it comes. And we all know fans like to, there's a centrifugal force to airflow. So the fan takes the air and it scoops it and it comes out in a cone shape. So this helps straighten some of that out as well. But obviously down here, up here, and right here is all obviously helping exhaust as much air as possible. So what I want to do now is I'm going to put it all back together. I'm going to turn it on and I'm going to check the airflow with our smoke meter, whatever, our smoke gun, if you will, because I want to see now, I'm curious how much air is being lost right here. I'm almost wondering if I wanted to do some more testing on this case, if I was to like tape this closed, would that help? Because some of the bottom air and some of the front air wants the path, air is a fluid, right? It is going to take the path of least resistance. And sometimes the path of least resistance is the first opening it sees. So I'm curious as to what the airflow is going to look like on the backside right here. All right, so starting with the bottom intake, it is open all the way around. So yeah, I don't see there being any, wow. Okay. But just as I thought, there's definitely air coming out the back. I see the smoke already going that way. So I almost feel like if there was a solid plate that you could get for that right there, that would even help airflow even more potentially, because any air that goes out right there didn't take any heat with it. Like it really didn't. So if we check right here, even though the bottom has the fan filters and everything going, there is absolutely no lack of airflow in the bottom. Now, if we look at the front right here, there we go. You can see it's definitely going, it's pulling air in from all the way out here. At the top right here. Yeah, no problem pulling air in at all. Look at that. Now, if we want to check positive pressure right here, you can see the air will be pushed out where the vents are. The fan's up here, as you can see. So that's the amount of positive pressure. Same thing on the bottom underneath the GPU. Oh, that's interesting. So because of the fact that we have the bottom intakes right here, sometimes if you only have front intakes and top exhaust, and you have a GPU like this that has an intake fan on the front and then this has a flow through, or if you have an axial style cooler that has all the fans on the bottom, with this opening in the back right here, if the GPU is not getting enough air, it can pull air in through that gap. But because we have the fans feeding it on the bottom, there's absolutely no air from the back of the case being sucked in through this opening feeding into the GPU, which could lead to warmer temperatures because it'd be pulling in hot air that's exhausted out the back. So you can see right there, like right at the top, maybe a tiny bit's getting sucked in, but because that bottom fan is also blowing up and making positive pressure right there, very little air can come in right there. We've done smoke tests where there's no bottom fans, and we've seen the front fan on a GPU pull in so much air on the back of the case that any smoke I would put right here, you would see it all go in that vent. Even though on the top, you could find positive pressure. That's just because there's pressure zones within a case. One other thing I want to see right now though is I'm curious if this power supply is pulling anything in right here, or if this 140 plus 140 plus 120 exhaust, this straight through air design, is actually pulling or overpowering it. Hell no, nothing. Look at that. Oops, give me back my thing. So what I'm gonna do now is I'm gonna put the glass back on and we're gonna take a look at the backside to see just how much air is actually making its way out through that back channel. Some, not a lot, but some. Okay, maybe it's not as much of an issue as I was concerned with. All right, we'll let this place clear out a little bit and we'll give you some final thoughts, I guess. Still looks like Snoop Dogg made a visit. Anyway, okay, there's an elephant in the room right here, and I'm not referring to me, by the way. I'm less elephant than I used to be. But anyway, I digress. There is something regarding this chassis that I didn't really consider until I really started looking at the data that really shows, one, how amazing this chassis is at airflow, but two, something you kind of need to know. So for instance, they talk about this being acoustic glass. And they're referring to it as acoustic glass because of the fact that it is laminated. Now, laminated is just a coating process that happens where if the glass breaks, it all sticks together. All the glass in your car is tempered glass because you want it to shatter, not turn into razor shards flying at you. But your windshields are laminated. That way, if something hits it, it stays intact rather than imploding into your face. Your side windows and your back windows, those explode, but your windshield stays together. Now, the only reason you ever hear about acoustic glass in cars is because it's usually double pane or double layered with an air gap in between, which one helps with insulation and two helps with sound deadening. That is not what this is. I think it's a neat thing to say, but realistically, the only benefit to this being laminated acoustically doesn't have any benefit at all because everything else is vented and openness in vents lets sound out. Okay, so that's like me going, I've got a whole wall of windows, but I'm only gonna soundproof the middle ones and say we're good. It's kind of BS as far as I'm concerned. It's not, the only thing that acoustically maybe changes is the frequency a little bit, but it doesn't change the volume of the noise coming through. But its benefit is obviously if the glass were to break, it will stay together, mostly, unless you go throwing heavy metal objects at it. But it still stayed together mostly. But what I'm referring to here is the King 45 had the biggest advantage over the BF 360 and the X50 from Hyte because of the fact that it was solid glass front and solid glass side. And with it being a chimney style only means less ventilation facing the microphone meant less noise facing the microphone, which meant I could run the fans faster to get to that same 42 dB normalization. The BF 360s having 180 millimeter fans that turn significantly slower, but moving a significantly higher volume of air than 120s means it had a significant advantage over the X50 over exchange rate at the same volume. Because this sucker has such an open perforation front grille facing right at the microphone meant the fans were running slowest in this case. So that's where the noise normalized dB is really interesting because it really takes into account nuances like that. Like if you have more solid panels, that means less sound can make it through. But this having so much ventilation, especially the front ventilation facing forward, means that the fans in this case were only running at about 42%. Versus everything, like in the King 45, the fans were running about 65%. Because these are Be Quiet fans, they're very quiet. So you really get, I know it's in the name, but you really get a wide range of RPM without a huge range in measurement of sound. Our dB meter is not as scientific as having like a chamber, but it's still better than just guessing. It's still something we can normalize on. So the X50 leading the charts, although barely, while having the biggest disadvantage to actual airflow through the chassis because of how much we had to slow the fans down, is pretty significant as far as I'm concerned. Now, noise is subjective. Some people are like, when I game, I just put my headphones on, let them blare. But we also showed that there's a diminishing return where turning them faster led to slightly worse temperatures. So I think it's one of those things where as long as you are exchanging enough volume of air to where the air that's entering your GPU and your CPU are not being starved of the air it's asking for, you're gonna be fine. That's why when you look at these case charts that are like 100 cases long, you might find the top 50 are only separated by 2 degrees, is kind of like what we're seeing here. But I think that's where you need to take into account other feature sets. So this is a $160 case with the glass side panel. It's $130 with the mesh side panel. The King 45 is a $99 case with no fans, which is kind of the way we tested it because we use our own fans. But this is $160 with no fans. And then the BF 360 is $199 for the Flow or Pro or whatever they call it, which comes with 2 of the 180 millimeter fans. But we also, that's $200. We also threw in 2 more 180 millimeter fans, which I don't know how much those fans cost. It's probably honestly like a $250 case at that point, which really kind of makes the Hyte X50 really that much better on paper as well, and when it comes to value. But the fact that you can fit all this hardware in there and it definitely wasn't causing any sort of thermal issues, the airflow is certainly well thought out. I think it's a pretty good chassis. Now, a lot of people think $160 is way too much for a case. That's subjective. That is subjective. Objectively, the case performs exactly as we showed compared to those 2 other cases, and this is where you as the consumer gets to decide where the hell you're gonna spend your money. All right, guys, thanks for watching. I get to, in spare time now, start doing this with a lot of other cases so that we can start building out that chart. Yay.